In this video, we'll look at exponents, particularly three rules: multiplying the same base, dividing the same base, and then we'll talk about the zero exponent. The rules are very simple. When you're multiplying the same base together, you add the exponents. So for example, 2 to the power of 7 times 2 to the power of 12, keep the base, it's 2, and add the exponents. Feel free to use a calculator, I won't judge. What's 7 plus 12? 19. That's it. When you're multiplying same base, keep the base, add the exponents. The same is true if it's letters. Here I have m to the power of 3 times n to the power of 2. When you're multiplying same base, keep the base and add the exponents. A lot of students confuse this with a power on a power. It's not multiply the exponents. A lot of people will put 6 here. When you're multiplying the same base, add the exponents. Whereas if you're dividing the same base, subtract the exponents. Here I have 17 to the power of 4 divided by 17 to the power of 3. So I'm going to keep the base and subtract the exponents. 4 take away 3 is 1. And note, when you have an exponent of 1, don't leave it. You'll get a communication error for that. 17 to the power of 1 is just 17. What was the rule? Dividing same base, you just subtract the exponents. So let's look at this one, even when it's a letter. X to the power of 21 divided by x to the power of 15. Subtract the exponents, but keep the base. You get x to the power of 6. It's even true when there's multiple, and I don't mind if you do them all at once. 3 to the power of 4 times 3 to the power of 7 times 3 to the power of 5. When you're multiplying the same base, add the exponents. 4 plus 7, 11. 11 plus 5, 16. You get 3 to the power of 16. And notice, I'm not evaluating, I'm just simplifying. On a lot of the activities and assignments I give you, it'll say simplify, don't evaluate. If I don't say evaluate, just leave your answer as a number with an exponent. I'm just simplifying. Let's simplify here where we have different letters, so we'll just multiply the same bases together. Look, I've got a squared and a cubed. So multiply these same bases together and add their exponents. So the a's are left over with a to the power of 5. Here I've got the same base as well. The base is b. So I will multiply the b's together. When you're multiplying the same bases together, add the exponents. 7 plus 3 is 10. And that's my final answer. I multiplied the same bases together and I added their exponents. When you've got multiple things in a fraction, apply your same rules. I can't multiply these top two together because they're different bases. I can't multiply these bottom two together because they're different bases. So I'm going to divide the same bases. I have 4 to the power of 6 divided by 4 to the power of 3. That leaves me 4 cubed. And since I have another number here, I'm going to need brackets. You don't need it with letters, but you do need it with numbers. Now I'm dividing the same base. 5 to the power of 9 divided by 5 to the power of 7 is 5 to the power of 2. That's your final answer for simplify, unless it says evaluate. Same thing with letters. Can't multiply x's and y's together because they're not the same base, but I can divide the same base, just like we did back here, by subtracting. X to the power of 12, keep the base, and subtract the exponents. 12 take away 4 is 8. Y to the power of 7 divided by y. If there's no exponent here, that's the same as just exponent 1. It's understood as a 1y, so 7 take away 1y leaves y to the power of 6. And that's my final answer. X to the power of 8, y to the power of 6. That's the end of my multiplying or dividing the same base part. Now let's look at the zero exponent. It's so easy, you just have to remember it. You won't believe how many students forget. Here in words is the simple explanation. Anything to the power of 0 is 1. So for example, 6 to the power of 0, 1. 21.5 to the power of 0, 1. Even a letter to the power of 0, 1. That's the whole thing. Even if you have a bunch of stuff in here, like 3x squared, y7, You can't do anything with that. But it doesn't matter. It's all to the power of 0. 1. And a lot of times on evaluations, I love to put some crazy stuff. 2 to the power 2 to the power 2. A student will call me over and say, what is this stuff? And I can't answer that. I mean, I can tell you this is pi. I hope you know what that is, because we're going to cover that in other lessons. But this is summation notation. You don't need this for the course. All you need to notice is anything to the power of 0 is 1. And that's the end of this video. We talked about multiplying the same base. We talked about dividing the same base. And we covered the 0 exponent.